Greetings from Milton Keynes in the United Kingdom. My name is Carsten Sills and my topic is how should Java developers build frontends for web, mobile and desktop today. If you're interested in the slides or the videos, if you want to have extra information, if you want to give me feedback, if you want to get started with some of the projects I'll be talking about today, or if you want to subscribe to my newsletter on Java, then please go to this URL. You'll also find it on the conference page. Or you just snap this QR code with your phone camera. Okay, so what's on the agenda today? Well, first I want to talk about how can we actually build front ends today? What are our options? Next is, what is it we Java developers wish for? Then I'll talk about the first of three scenarios, which is how to build a new web application today. The second scenario is how to build new native iOS and Android apps. And the third scenario is we do have a web application, what do we do on the desktop? Now I give you advice, so it's just fair to ask, what's my angle? Well, I've been a full-stack Java developer for 22 years, web initially and now mobile over the last couple of years. But don't be afraid, it's not one of these talks where somebody did something once on a project and now wants the whole world to do the same. I'm giving you 12 criteria backed by research so that you can hopefully make your own decision. You can use my criteria, you can weigh my results differently, but it's, hard, hopefully objective criteria. So I'm not here to sell you any courses or books. I'm not affiliated with the projects that I'm talking about. So in the end, I give you options, but you actually decide. So you need to use my criteria, your own rating. You weigh criteria differently. You need to take your environment into account. And in the end, it's your decision. So, with that out of the way, let's get to the first point on the agenda today. So how can we actually build front ends today? Well, first of all, we need to figure out what kind of applications and devices are we talking about. So I'll focus here on enterprise applications. We're Java developers, so we're building enterprise applications. So we're talking about forms, we're talking about data grids, we're talking about reports. So it's not about games or media players. The devices are PC first, so it's Windows, Mac, and Linux, but then also mobile, where we have iOS and Android. So how can we build these applications? Well, first I want to tell you how we can go safe. And safe means whatever options we pick, we are very certain they're still here in 5 years. And there are two ways for that. The first one is the web. Okay, so we build one application that runs everywhere. That's probably the most common way. The other safe option is native. We build one native application, well, actually 5 native applications for these 5 different platforms. So how these two options compare? On the web, we've got one code base. We like that. Native, we've got 5 different code bases. We don't like that. The web generally is slower, and native produces faster applications. Now, for our purposes of enterprise applications, we're fine with the web, most of the time at least. The web has less features, especially on mobile devices, on iOS. The mobile applications can't do as much. There's push notifications, or you've got less data storage on devices. Generally, not as much as you can do on the native devices. And you also don't always have access to all of the hardware features. Now, as a native application, you've got all the features of the underlying platform available. The web uses JavaScript, which we don't like as Java developers, but what we even like less is that we've got 5 different languages when we build native applications. Debugging is difficult on the web, especially, if you have a mobile device and you want to step through your code. That's hard to do, whereas debugging is very easy when you build native applications. Can we combine the advantages of both of these approaches? And yes, that's the promise of cross-platform applications. And we'll talk about cross-platform frameworks here. See if they actually fulfill that promise. But before we do that, we need to talk about the state of the art when building front ends today. And that's what I call declarative, what the industry calls declarative. So what does it actually mean? I looked for a good definition of declarative, and it's hard to find. So let me explain with an example, and that is Apple's Swift UI. So we've got a very simple application with a counter and a button. So that blue thing there is a button. And so if we look at the code that's behind that, we see that we've got a state variable called count at the very top. It's marked by that annotation, that state annotation. And then we've got a text label that displays the state of that variable, displays the count, which is currently 0. We've got a button underneath it. We see the button has an action handler, self-count +1, and it's got a label. And so let's go through the application. It all starts with pushing the button. So when we push the button, then the action handler fires and increases the value of the variable by 1. And so now the count goes from 0 to 1. And now the framework takes charge and repaints the UI, updates the UI. But there's really only one thing that has changed: the counter. The counter is now increased. And so it goes from 0 to 1. Wonderful. So what was that? What do we actually see? And how is it different from other approaches? I would say there are 3 major differences. The first thing that we see here is that everything is code. There is no UI builder. Xcode has one, Visual Studio has one, Android Studio has one. We don't use them anymore. Everything is code. The customization, the adjusting of the user elements, everything happens here in code. And we have the status clearly marked so that the framework knows there is a status variable called count, and then we've got events that fire. And the framework drives the update. So it's not our button that says repaint everything. Our button can only indirectly update the UI by changing the state, and then the framework drives the updates of the UI. So to sum up again, declarative means 3 things. Our front end is built in code. We have status and events in our components, and the framework drives the updates. Now, how important is that actually, this approach? Well, you've already seen that we used Swift UI, which is the default way of building front ends on iOS and macOS today. Now, React Native does the same thing on iOS and Android, but React has had declarative front ends on the web for years. And then we have Jetpack Compose, which will be the new way of building front ends for Android. It's in beta right now and will be 1.0 somewhere later this year. You can think of it as Flutter for Android. And Microsoft gives us an option too. It's called .NET MAUI, which is not just an island in Hawaii, but also stands for Multi-Platform App UI. Its targeted release date is November 21. So, if we step back, then we see declarative front ends being the recommended option for iOS and macOS today, for Android later this year, and being an option later this year for Windows as well. That's why I'm saying the state of the art today is declarative front ends. So why am I harping on about state of the art so much? Well, there's 2 reasons. Number one, if we ever need to change frameworks because, let's say, Flutter doesn't work for our project and we switch to React Native, or neither of these two work and we switch to native iOS and Android, then we lose our code, but we don't lose the knowledge, the approach. And so it gets easier for us because all of the frameworks work the same way. They all are declarative frameworks. So changing frameworks is easier. So your boss is happy. But it also gives us a bit of job security because it makes it easier for us to learn other frameworks. So we are happy. So which web frameworks are we looking at? In alphabetical order, we have Angular from Google, JSF from Jakarta EE, React from Facebook, ThymeLeaf, Vaadin, and Vue.js. Now we're not going to look at all three of them today because these three frameworks are out. Why are they not going to be discussed here today? Well, ThymeLeaf and JSF are not declarative. None of them are very popular, and ThymeLeaf and Vaadin are not safe, so we're not sure they're still around in 5 years. You can find some more information about them on my talk page, but I'm not going to discuss them in this talk. So instead of 6 options, we have just 3. So for cross-platform frameworks, I initially looked at, again in alphabetical order, Flutter from Google, JavaFX, initially Sun/Oracle, now with Gluon, React Native from Facebook, and Xamarin from Microsoft. And here again, Xamarin and JavaFX are not going to be included in the talk because neither of them is declarative, neither of them is popular, and JavaFX is not safe. We're not sure they're still going to be around in 5 years. And for Xamarin, there's lots of changes coming, so none of these 2 options will be included in the talk. Again, you can find more information on the talk page. So we are down to just 2 options. We're not going to be talking about native frameworks because compared against cross-platform options, there's just too much effort for too little gain for our use case of enterprise application. So to sum up front ends, we're talking about enterprise applications for PC and mobile. The state of the art is declarative front ends. For web, we're going to be looking at Angular, React, and Vue.js. For cross-platform, we'll consider Flutter and React Native. And so we've got our first agenda point covered, and let's move on to the next. So what do we Java developers wish for? And here are the 12 criteria that I promised you at the beginning of the talk. First of all, we'd like to use Java for writing our front ends. We'd like our front ends to be declarative because we just learned that's the state of the art. We want to pick an option that's safe, something that's still here 5 years from now. We want to pick a popular option. We want to build web, mobile, and desktop applications. We want to have lots of extensions, libraries, so that we don't have to write all the code ourselves. We want fast applications. We want to access native functionality. We want to have just one code base, and we want to have a fast build, deploy, and debug cycle. Why am I so interested in popular frameworks? Well, it's easier to learn because there's more articles and videos and more courses available. There's more tool support, so build, deploy, and debug is easier. It's easier to hire developers because there are more of them that know these frameworks. And it's easier to program in framework X when everybody tells you that X wins, because otherwise you have to justify to your colleagues and your boss why you're using something that doesn't win. Why do you choose to use technology Y? It's clear to everybody that X wins. How do we know whether a technology is popular? First, I looked at developers and what they do. More specifically, I looked at the number of questions at Stack Overflow as a data point and how many students paid money for courses of a particular technology at Udemy. And then I'm looking at it from the employer's perspective. how often is a technology being mentioned in job ads at Indeed? Indeed is the largest job portal in the world. I looked at 61 countries. They represent 92 of the worldwide GDP. Multiple technologies can be mentioned within a single job ad, and just because technology is mentioned doesn't mean that it's the only requirement for a job. So here's our wish list with the 12 criteria. And that means we've got our second agenda item covered. So on to the web application. Just a reminder, we're looking at Angular, React, and Vue.js. So how popular are they? Let's look first at the questions at Stack Overflow. So data goes back to about 2014, and we've got Vue.js first. That's the green line. We see it flatlined in about 2020 and stable ever since. Angular peaked in 2018 and has been declining ever since. And React is just always increasing since it first showed up here. Now it's got about 5% of all questions, so 1 in 20 questions on Stack Overflow is about React. If we say that Vue.js is 1x, then the number of questions for Angular are 1.6x and 4.3x for React. Now let's look at how many students courses for a particular technology have at Udemy. So again, if we take Vue.js as 1x, then Angular is 2.6x and React is 3.1x. Now let's look at mentions at Indeed globally first. And again, Vue.js is 1x. That means that Angular is 1.7x and React is 1.9x. So clearly most jobs for React, then a little less for Angular, and then Vue.js with 1x. Now if we look specifically at Asia Pacific, then the picture is slightly different. This time when we say Vue.js is 1x, then Angular is actually a little less popular here as far as job advertisements are concerned, and React is just a little ahead of Vue.js. So Vue.js is clearly more popular in Asia Pacific. So, but if we sum up, we can say React is the most popular technology, Angular is second, and Vue.js is third. So how do they compare when we look at our wish list? Now, not all of these items on the wish list apply to web, so let's take the ones off that don't apply. The language, I think, is a clear winner. That's Angular. Angular uses TypeScript, and TypeScript is closer to Java than regular JavaScript, which the other two frameworks use. React is the most declarative framework. You can also build declarative applications with Angular and Vue, but it's more natural and more recommended approach in React. I think that React is the safer option here compared to the other ones. It's also the most popular one. Now, I think for building web applications, all three frameworks are fine, so I don't think there's a particular winner here. I'm not sure that any of these three have a commanding lead when it comes to libraries and additional frameworks, so I don't declare a winner here. React produces the fastest application. You can find some details on why I say that on my talk page. And when it comes to build, deploy, and debug, I'm not sure which of them is the fastest. So if we put all of that together, then we can say that React is the winner, Angular is second, and Vue.js is third. So what's my advice for building web applications? If you have an existing web application, then keep it if it's React, Angular, or Vue.js. If you use any other technology, please think about migrating to these three technologies. Now, most of the time, migration doesn't make business sense because it costs a whole lot of money just to replace the front end. But still, look at migration, even though it often doesn't make business sense. Now, if you start a new project or if you do migrate, then I recommend you look at React first, then Angular second, and Vue.js as the third option. So we covered web and now on to mobile. Here we're looking at two frameworks, Flutter and React Native. We're also looking at popularity first. So questions at Stack Overflow. Going back to about 2015 when they first showed up. So React Native flatlining for the last year and Flutter still increasing. So if React Native is 1x, then Flutter is 1.8x. So lead here for Flutter. Let's look at students at Udemy next. So React Native, if that's 1x, then Flutter is 1.6x. So also more students. Now let's look at jobs. First, global. And here React Native is in the lead. If we say that it is 1x, then Flutter is 0.5x. Looking at Asia Pacific specifically, then the lead is less commanding. Flutter then has 0.7x, so closer to React Native. But because React Native has a lead in jobs, I declare it to be the more popular of the two technologies. Now let me tell you specifically about my experience of building a native iOS and Android app with Flutter. So what is Flutter actually? I'll let Google speak. So here are the important words. So Flutter is for building beautiful natively compiled applications for mobile, web, and desktop on a single code base. That's certainly very ambitious. So let's compare React Native and Flutter. React Native uses JavaScript. Flutter uses Dart. Dart is better than JavaScript. You're going to see that in a second. So here, that's a plus for Flutter. React Native is a bit slower when rendering because everything runs through a JavaScript bridge. Flutter renders faster. It uses Skia, the rendering engine that also Firefox and Chrome use. React Native uses the native UI elements of Android and iOS. Flutter doesn't use the built-in iOS or Android or browser elements. Instead, it emulates them. That's a downside, and we're going to be talking about this later today. React Native doesn't officially run on the desktop, but there's ports for Windows and macOS maintained by Microsoft. You can find more on the talk page, whereas Flutter officially supports Windows, Mac, and Linux. When you build a web application and a mobile or desktop application, you have two code bases. You've got a React project for the web and React Native for mobile or desktop. In Flutter, you actually do have a single code base. Now, I talked about Dart, and you may ask yourself, well, why can't we use Java instead of Dart? Why do we have to learn a new language? Why can't we just write Java code, like this? Well, what if I tell you that this actually is Dart code? If you look closely, then you see, yes, this list class gave it away. A list is an interface in Java. So in Java code that you see here, you need to instantiate a linked list. So what is Dart? Google originally built Dart for the browser. It didn't work there, but now it's a simplified Java for building UIs, for building front ends. You can find more details on what simplified means on the talk page. When you develop with Flutter, it runs in a virtual machine, but when you deploy it, it's compiled into native code. If that sounds familiar, that's exactly what GraalVM does in Java. I talked about emulated UI elements. So what kind of emulated UI elements do we have? we've got material design elements, which are the native UI on Android, and they're also available on web and desktop. For iOS, iPhone, and iPad, you've got the iOS elements, and then you always have low-level elements, shapes, squares, circles, lines that you can draw yourself. So those three are the ones that are available to you, and most of us will be using either material design or the iOS elements. How does Flutter run? You can build standalone applications, that's what I'm doing in my project, or you can just fill some screens in an existing native application with Flutter. Talking about native integration, how does that work in Flutter? For the most part, you'll be using plugins. So for camera, files, pictures, access to location, or the map, you use plugins. So from your perspective, it's just a Dart code, a plugin that you add to your Flutter project. You can also put in native screens of the underlying platform if you need to integrate something. That's, for instance, how the Google Map plugin works. It uses native iOS or Android screens. And if that's not enough, then you've got two more options. You can talk to native code through channels, which is publish and subscribe. For instance, if you want to set geofences or receive native notifications, then you can use these publish and subscribe channels in both directions. And if that's not enough, there's also a C API available to you. In Flutter, there's really fast build and deploy, which is important because on mobile, you typically have slow builds. So it's easily possible to wait, 2-3 minutes until the iOS app is ready for your iPhone. And Flutter has hot reload, where your changes get applied immediately. And it also has hot restart, where in a couple of seconds your application is reset and you can start anew. And this is faster than native development, so let me show you. In my running Flutter app, I'm going into a form. And add address line 3 in the code. I save the code, and Flutter adds the address line 3 immediately. Flutter even kept the cursor in address line 2. Wonderful. So hot reload really is fun and keeps the flows. Instead of, waiting 20, 30 seconds or even more for your application to redeploy, you make a change and it immediately shows either on your emulator or your real device. Flutter also has a lot of plugins, about 15,000. Most of them are open source on GitHub. It's got a pretty good portal, which gives you a lot of information about these plugins, including versions, changelog, example code, code quality. And if one of these plugins doesn't work for you or has a bug, then you can fork it on GitHub and easily add it to your project, the fork. So you don't need to publish it. Instead, you just take your fork URL of your own GitHub repository, add it to your Flutter project, and you're off to the races. So let me sum up what I think is good about Flutter. Dart is a simplified Java for the UI. It has simple native integration. We get fast code build and deploy, and plugins save us time. So what are the issues that I have with Flutter? What are the things that I don't think are good? Well, the first one is, will Google kill Flutter? Google has a reputation of killing projects. There are even entire websites dedicated to projects killed by Google. And here you see some of them. And of course, the answer is, we don't know. What's bad about it is that Flutter has in-house competition. Angular is a framework that you can also build to deploy to mobile. We'll soon have Jetpack Compose, which is Flutter just for Android. On the plus side, Flutter is the UI framework for Fuchsia, the mysterious Google project that you may have heard about. And it's also popular outside of Google. So Toyota, for instance, recently announced that they're going to use Flutter to build in-car entertainment systems, and back in 2019, the last time that we had these numbers, Flutter was number 3 for contributors at GitHub. It was about 13,000 people that contributed to Flutter at that point in time. Can we actually really build mobile web and desktop with one code base, as Flutter promised? And the answer is no. Why am I saying that? Let's look at the desktop part first. Desktop is only in preview. It entered preview in March. There are no native UI elements on the desktop, so you can't build a native-looking Windows or macOS application. Ubuntu Linux has announced that this will be possible, but Ubuntu Linux is, of course, a niche product. So the recommendation from Flutter is to customize the material elements that are part of Flutter, but that doesn't give us a native-looking application. This may be fine for your use case, it may not be. Similar on the web, Flutter just recently entered 1.0 on the web. You can't get web elements and style them with Bootstrap or other technologies like you can in other web projects. Instead, you again have to customize the existing material elements. This may work for your project, it may not. And 15,000 plugins sounds impressive, but on NPM you've got hundreds of thousands of modules for Node or JavaScript applications. So that's a disadvantage here too. Next one is when you turn your phone to the side, then we often want the application to look different. Here is an example for my application. These two cards on top of each other when the phone is in portrait mode and next to each other in landscape mode. So that happens when you rotate your phone or you have a big phone to start with. And interestingly enough, there isn't really a good solution in Flutter. So my solution here is I used a plugin that transfers the Bootstrap grid into Flutter and allows me to build such UIs. Native design for mobile is another issue. On iOS, some of the components are missing. For instance, we still don't have a table view, which is quite common in iOS. It's also time-consuming to build an application that's both native on iOS and Android. And so my solution is to build my own components on top of plugins on top of Flutter. You can also get the impression that the Flutter team is overwhelmed and can't cope. So there's lots of issues out there that are open. Everything is in the open on GitHub, although recently the Flutter team closed more issues than new issues arise. There are also some long-standing issues, but at least some of them get addressed. For instance, the animations on iOS can be quite janky. That's the term if they don't run smooth, but that's being addressed right now. Flutter also has to serve new platforms. Desktop just entered the preview mode, so we've got Windows, Mac, and Linux, and web is just 1.0, so lots of work on these new platforms. Null safety is a feature that got introduced with Flutter 2.0, which means all the existing plugins need to be updated eventually, so that brings in a lot of uncertainty and a lot of work into the ecosystem. But in good news, the Flutter team recently hired external developers to maintain some of the Google plugins for them because they just didn't have the time to do it themselves. So sum up, what do I think is bad about Flutter? Everybody will ask you, will Google kill Flutter? You don't really can build all the clients, all the applications with one code base. The responsive design is a little bit unclear, so you have to find your own solution. Mobile native design is time consuming, so if you do that, it's more work than it should be. And sometimes it can feel like the Flutter team is overwhelmed. So how do Flutter and React score on our wishlist? Well, Java, that's no contest. Flutter is the clear winner. Dart is very similar to Java, unlike JavaScript. They're both declarative, so I don't declare a winner here. I think React is a bit safer than Flutter, at least in public perception. React is also more popular based on the number of jobs. I think React is a more mature web platform compared to Flutter. I think for the kind of applications that we build, there isn't really a clear winner for building mobile applications. I don't think there's a clear winner on desktop either. The support for Windows and Mac is unofficial in React Native, but in Flutter it's in beta and you don't get native UI elements. I'm not sure which of these two has more extensions. I think Flutter builds faster applications and gives you easier connectivity to native functionality. Flutter really has one codebase. React and React Native is two codebases, and I'm not sure which of them gives you a faster build, deploy, and debug. So, to sum things up, I declare Flutter the winner and React Native to be the second place. Now, if you recall in the beginning, I said you may provide your own criteria or you may weigh them differently than I do. And here is such a place where I could say, well, clearly React Native is the winner. React wins in web development, so that means lots of people are going to use React Native and there are more jobs available. So you may declare React Native to be the winner in the mobile framework. So what's my advice on mobile? If you have Flutter or React Native, you can just keep it. Otherwise, think about migration. If you start a new project or you do migration, if you use React on the web, then you use React Native first and then Flutter if that doesn't work out. Otherwise, you start with Flutter first and then use React Native. And so we covered mobile as well. On to the desktop. And the bad news is on the desktop, there really is no good option here. There's lots of change in the desktop world. Windows, for instance, there's a .NET 6 release coming in November. There's a Fluent Design language that Microsoft is introducing, lots of change there. And the same is true for macOS. So Apple introduced a new design language and uses SwiftUI. Desktop applications have always been expensive because installation and support on the desktop is more expensive. And finally, the web is good enough for enterprise applications because that's literally how most of our customers, the enterprise users, get their web applications today. So that's why my advice for the desktop is keep your web application on the desktop. Only if Material UI elements work for you and you use Flutter, then evaluate whether Flutter for desktop is an option. So that wraps up our last agenda item. Do I follow my own advice? On the web, yes, I do. I build my application in Angular, but I do learn React and I hope to just use React on future projects. On mobile, I use Flutter, and for the desktop, we use the web application. So here's the summary. For the web application, my advice is keep your application if it's built with React, Angular, or Vue.js. Otherwise, think about migration. Again, mostly doesn't make sense business-wise. If you start a new project or you do migrate, then try React first, then Angular, finally Vue.js. On mobile, keep your application if it's built with Flutter or React Native. Otherwise, evaluate a migration. If you build a new application or migrate, and use React Native first, and then Flutter if you use React. Otherwise, the other way around. And for desktop, keep your web application on the desktop, and only if you use Material and Flutter, evaluate Flutter for desktop. So that's the end of my presentation, and just a little piece of advertisement. I'm looking for a project starting in October 21. A full stack Java project, Spring Boot, Angular, Flutter is my preferred option. And I'll work as a contractor or fixed term employee. Milton Keynes, London, or remote. But back to our presentation here. So slides and video, extra information, chance to give me feedback, chance to get started, and a chance to subscribe to my newsletter is available at this URL. Thank you.